Hey guys, today what we're going to be looking at today is linear growth. So when we look at a linear equation or a context of a linear equation, we can figure out what it'll look like. So let's go ahead and look at our first example. Now it says Gavin is buying tomato plants to plant in his local community garden. Tomato plants are $9 per flat. A flat contains 36 plants. There are no partial flats. So what this is saying is if you ever go to Home Depot or like a gardening store, you never usually buy one flower. If you want to buy multiple, you kind of buy them. They look like a grid like this, and there's a ton of them that come in here. So it looks something like this, where you would have a big thing, and each one of these sections would have one plant in there. So it would look like this, and then it'd also have rows coming down like this. And so they're separated. And so when you are buying it, you're really buying, this is called a flat, and each one of these would actually have a tomato plant in here. So you'd have a plant in here, 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 so on and so forth. So you have one of these, and every time you buy one flat, it is going to have 36 plants in it. So there's going to be 36 little rectangle squares in here. And each one of those costs $9. Now you can't go to Home Depot and let's say these are all filled with plants. You can't buy them partially filled. You can't say, hey, I only want 18 of these 36. You have to buy all of them. So it says state the independent variable. It's the number of flats you buy. It's the number of flats. So remember, those are just the tomato plants. Now state the dependent variable. It's the total cost. All right, so now once we have that, it says go ahead and fill in this table. Now remember, it says X is the number of flats. And the Y variable is total cost. Now, if we remember, each flat costs $9, which means 4 of them would just be 4 times 9. 4 flats, they're $9 a piece for $36. If we continue this, 5 times 9 is 45. 6 times 9 is 54. 7 times 9 is $63. So state the rate of change. What does that represent? So remember, the rate of change is just the change in Y all over the change in X. So when I changed from 36 to 45, that was 9. The change from 45 to 54 was also 9, so on and so forth. Now the change on these, from 4 to 5, 5 to 6, 6 to 7, is just 1. So if I were to write this, we would have 9 over 1, 9 over 1, 9 over 1. So obviously these have a constant rate of change, which is 9. What does that represent? For every one flat I buy, it will cost $9 more. $9 more. Cool. All right, so now it says state the rate of change. What does the number represent in this context? I believe we just answered all that in this one, so let me make sure if I didn't mess anything up. Yeah, state the rate of change. What does it represent in that context? Cool, so we're already done with that one. Now it says, is the relationship proportional? Use the context to justify. Well, right off the bat, if I were to buy 0 flats, that would cost me $0. Since it contains the point of 0, 0, which means the graph would go through the origin, I know for a fact it would be proportional. Now, if we're using the graph, so let's go ahead and go back to this graph. Remember, what we would want to do is just look at the numbers to see if it's proportional of Y over X. Not change in Y over change in X, that's for rate of change. But for just Y over X, this would be 36 over 4, which is 4. 36 over 4 is 9. 45 over 5 is 9. 54 over 6 is 9. And 63 over 7 is also 9. Since the proportion of Y over X all equals 9, this would be a proportional relationship. Now it says make a graph and label each axis. So if I buy 0 flats, that costs me $0. If I buy 1, it'll cost me 9, 2, 18, so on and so forth. And I'm just going to graph the ones that we had. So 3 would be 36, 5 would be 45, 6 would be 54, and 7 would be 63. And as you can tell, this is a linear relationship. They make a straight line. And it says label your axis. This is the number of flats, number of plants I'm buying, and this is total cost. So there we go. All right, now should the graph be discrete or continuous? Basically what it's saying is, should the graph look like those dots, or should I have a straight line where it would look something like this instead of the blue dots? Let me make sure I got my correct line. There we go. Or should it look something like this? Now, if we had a straight line, that would represent we can buy any amount of flats we want. That means we can buy 1 flat, 2 flats, but it also represents you can buy part of a flat. And remember, it says you can only buy 1 whole flat or 2 whole flats. You can't buy partial in the directions. So this, if it's continuous, it would say that mean that we can buy half a flat, we could buy a quarter of a flat, we can buy 1/3 of a flat, which is not true. Only the whole numbers are correct answers. Therefore, it would be discrete. So should the graph be discrete? And we would write yes, because you can't buy part of a flat. Because you can't buy part of a flat. All right. So show the rate of change on the graph. So the rate of change is how much am I increasing by. So on here, the rate of change is when I increase, the dollar amount increases by 9 when my flat increases by 1. So that's the rate of change right here. I went up $9 for every 1 flat. So I went up by $9 for every 1 flat. So those little stairs that we made there represent the rate of change. And it says state the coordinate of the y-intercept, and what does that represent? Now we already graphed the y-intercept. That was the point where it was just right here at the origin. What that means is if I buy 0 flats, that means I'm going to have to pay $0. They're not going to charge you for anything. All right. Now let's go ahead and look at the last one. How many flats can Gavin purchase if he has $150? So let's see. Remember, total cost is, sorry, I made a mistake. Total cost is y equals $9 a flat. And it says I have $150 and it's going to be $9 a flat. So to figure out how many flats I would buy, I would just divide both sides by 9. And that would give me the total amount of flats I can buy is equal to 16 and 2/3. But remember, we cannot buy part of a flat. So if you use your calculator, it would be 16.6 repeating. You can't buy part of a flat. So therefore, the most amount of flats you can buy is just 16. All right, how would the context change so that the relationship between total cost and number of flats is modeled by the equation y equals 10x plus 5? So one more time, this is total cost, and this is the amount of flats. Now, amount of flats, this is the cost per flats. So the last part we need cost per flat. So the last thing we need to do is figure out, we need to make up a story of what does that 5 represent. That 5 can represent anything. Now remember, he says he's at a local garden. So he's not planting these in his backyard. So maybe if he's like lives in the city, they might have an area where people can purchase like little gardening boxes and they would rent them out. So maybe this is the amount he pays to rent the garden box. So rent the garden box. And I got all that information in the very front of the problem. So let's go ahead and write that. So it'd be the total cost. Sorry, I don't know why it's doing that. So the total cost is $10 per flat. Plus $5 to rent. Now you're renting the space for the gardening. Rent space to plant your plants. So hopefully that helps you guys set it up a little bit. All right, guys, so that's the end of the lesson. If you guys have any questions with this example or any others, please feel free to email me or your teacher.